Picture this. You are standing in a windowless room, and it is completely, utterly pitch black. You literally cannot even see your own hand waving right in front of your face. But you can feel something. The walls of this room are heated by a massive furnace hidden right behind them, radiating this incredibly faint, invisible warmth. Now, imagine if your skin could somehow eat that invisible heat coming off the walls and turn it into the exact amount of energy you'd need to go out and run a marathon. It sounds like science fiction, right? Well, there is an impossible group of deep-sea organisms doing exactly this right now. They aren't sitting around waiting for the sun to shine. They are actively parasitizing the heat signature of the Earth itself. Scientists call this mind-bending survival mechanism blackbody radiation harvesting. Basically, we are talking about extreme deep-sea life capturing an unimaginably faint, completely non-solar infrared glow and using it to actually fuel their biological metabolic processes. They are, for all intents and purposes, pulling energy straight out of the dark. And I am just absolutely obsessed with this explainer, because this discovery completely shatters our fundamental understanding of how biological energy works. For the longest time, we thought photosynthesis strictly required photons from a star, a sun. But this massive paradigm shift proves that life can actually sustain itself entirely on the hidden, internal furnace of a planet. It is literally photosynthesis in the dark. Part 1. Life in absolute darkness. So let's take a trip down to the ocean floor. We are dropping down to depths exceeding 2,500 meters. This is a crushing, completely aphotic environment. And aphotic just means an area that is entirely cut off from the sun's rays. Down here, sunlight is snuffed out long before it ever reaches the seafloor. It's a realm of absolute freezing darkness, populated by these superheated underwater chimneys that spew out mineral-rich water. You've probably heard of them, hydrothermal vents. Now, for decades, the old school of thought was that life down here survived purely on chemosynthesis. That meant organisms basically acted like chemical batteries, depending entirely on chemical reactions with stuff like hydrogen sulfide just to get their energy. But recent spectral data captured by autonomous submersibles totally flipped that understanding on its head. They found these microbial mats living right near the active chimneys, and they were exhibiting peak absorbance in the near-infrared spectrum. The new discovery? These little guys use dual-mode energy. They aren't just chemical batteries anymore. They are passive solar thermal collectors. And when you think about it, this perfectly explains why life would even bother to evolve such an incredibly complex system in the first place. Chemosynthesis is great, sure, but it is severely limited by the unpredictable flow of those vent fluids. If a hydrothermal vent suddenly quiets down, well, your chemical energy just dries up. Game over. So by developing the ability to harvest thermal infrared energy right from the faint glow of the vents, these organisms created a redundant energy buffer. It is a brilliant evolutionary survival strategy. They essentially built themselves a backup generator, allowing them to survive during the wildly unpredictable and, frankly, dangerous fluctuations in the vent's output. Part 2. Catching the invisible mist. Which brings us to exactly how they pull off this biological magic trick. Let's really dig into the physical mechanics of these massive semi-crystalline chlorosome-like antenna complexes. To really wrap your head around just how unbelievably sensitive these biological antennas are, think about how we humans usually capture energy. A standard solar panel sitting on your roof is basically like a bucket designed to catch a heavy, roaring downpour of rain. It needs a massive, constant amount of light to do its job. But an extremophile antenna, that is more like an infinitely fine mesh screen, designed to catch individual, microscopic droplets of mist floating in the air. Because the infrared light down at the bottom of the ocean is so incredibly dim, these organisms build massive, sprawling surface areas just to capture the most sporadic, faint infrared flickers. They are desperately funneling every single microscopic drop of energy into their biological engine. And once that incredibly fine mist of energy is finally caught, the conversion process kicks in. And it works flawlessly, kind of like a tiny microscopic hydroelectric dam. Imagine a slow, incredibly weak trickle of water making its way down a mountain. Instead of letting that precious water just evaporate or wash away into the dirt, you build a highly engineered series of tiny cascading water wheels. Step 1. An infrared photon, our tiny trickle of water, strikes the antenna. Step 2. It elevates an electron, which then carefully cascades down an energy gradient, slowly turning those tiny biological water wheels. And Step 3. It releases small, perfectly manageable packets of energy to create a constant, steady supply of electricity, which in biology is called ATP. By breaking this whole conversion down into incremental, delicate little steps, it prevents even a fraction of that energy from being wasted as heat. And just let this sink in for a second.
This incredibly delicate, perfectly optimized biological engine is operating 2,500 meters underwater, in total darkness, under pressures that would literally instantly crush a car. Part 3. Quantum Biological GPS.
But hold on, because it gets even stranger and so much more advanced. Let's look at the staggering structural plasticity of these pigment protein complexes. See, these organisms are not just static rocks sitting in the dark, they are incredibly dynamic. If the hydrothermal vent suddenly becomes dangerously active and super hot, the organisms will physically retract their antenna arrays so they can avoid oxidative overheating. Then, as they drift further out into cooler, dimmer waters, they expand those same arrays to capture more of that faint light. Think of it literally exactly like a person adjusting their coat according to the weather. On a warm day, you unzip, you shed a few layers to stay comfortable so you don't overheat. On a freezing day, you bundle up, increasing your surface insulation to keep your core temperature stable. These organisms have membrane-bound sensor proteins that are constantly reading the ambient heat and zipping or unzipping their biological coats in real time.
And now we reach the quantum mechanics that run this entire operation. The absolute most crucial point here is what happens in the literal milliseconds between capturing that photon and actually storing the energy. This is where we see quantum coherence at work. Quantum coherence is a state where an electron exists in superposition. That means it is literally testing multiple energy pathways simultaneously. To visualize this kind of quantum tunneling, it's very akin to opening up the GPS navigation system on your phone and having it calculate every single possible route through dense city traffic simultaneously. But instead of just picking a route and kind of hoping for the best, the energy tests all of them at the exact same millisecond and automatically takes the single path of least resistance to the reaction center before it even truly begins its journey. Because of this quantum GPS, the energy moves through the protein complex with almost absolutely zero energy loss. It's perfection.
And this flawless quantum efficiency is the precise reason these organisms are even able to survive. Because they lose zero energy in the transfer, they can maintain a cellular metabolic rate in an extreme environment, where classical thermodynamics practically dictates life should be frozen into total stasis. They are doing the impossible by perfectly mastering the microscopic.
Part 4. Aliens and Infinite Energy. So, why does all of this matter to us? Let's zoom out from the microscopic mechanisms and look at the massive cosmic and industrial implications of this discovery. First off, this profoundly changes astrobiology and the entire search for extraterrestrial life. We no longer have to exclusively hunt for perfect Goldilocks planets that have perfect atmospheres and bright suns. Our focus immediately shifts to icy moons right in our own solar system, like Europa and Enceladus. Sure, they are covered in massive frozen shells, but beneath those shells lie vast, subsurface liquid oceans and very likely volcanic activity. If complex life only needs a planet's internal heat to photosynthesize in the dark, then we can absolutely start hunting for thermal harvesting biological zones hidden deep within the crusts of alien worlds.
But back here on Earth, the materials science roadmap is just as wild. Let's look at the timeline. Right now, in the present day, human industrial machinery dumps just massive amounts of waste heat into the atmosphere. It has entirely lost energy. But moving to the innovation phase, there is incredible development coming down the pipeline involving synthetic benthic membranes. These are artificial materials engineered to perfectly mimic the deep-sea antennae we just talked about. And finally, in the very near future, instead of factory heat acting purely as waste, these membranes will reclaim that ambient infrared radiation, turning environmental waste heat into electricity to run entirely new secondary power grids. And this represents a massive, necessary shift in how we think about power. For decades, we've relied heavily on a solar maximalist approach, trying to catch the full, roaring, intense power of the sun using materials that demand really high energy to even work. But the benthic mimetic approach teaches us the exact opposite. It's all about catching individual infrared whispers. It's the new paradigm of opportunistic, low-energy reclamation. Think about it. Every vehicle, every computer, every single building emits an infrared glow. Right now, to us, it's just noise and waste. But these deep-sea microbes prove that this noise is actually an untapped ocean of power. Which leaves us with this one final thought. If life has spent billions of years learning how to not just survive but thrive in the absolute darkest, most scarce environments on Earth by simply capturing the subtle heat radiating around it, what happens to human civilization when we learn to do the exact same thing?
What happens when we finally transition from an energy scarcity model to a circular universe of infinite, low-energy harvesting? The blueprint for our entire sustainable future isn't up in the sky. It's been hiding this whole time in the crushing, dark silence of the ocean floor.